right? Following inequalities. Graph the following inequalities. So we're going to start off with 6x plus 5y is less than -10. Oh, that one was actually part of the worksheet, right? Anyways, just write it down. It's okay. We'll figure it out. I'm going to show you a shortcut. That's why I'm using this. So if you've done this already, good. So you see x and y, right? So you know it's going to be a diagonal line. You notice that this is an inequality, so shading will need to be involved here. So I'm going to start the usual way with finding the intercepts because I can tell that this is not going to be a horizontal or vertical line. That's why the other one I just went straight to simplifying it. And so x-intercept, the y turns 0, right? So 6x is equal to -10. And that is -1.67. -1.67, 0. Here we have 5y is equal to -10. Divide both sides by 5. Y is equal to -2. 0, -2. Got that taken care of. I'm going to rewrite. So 5y is less than -6x minus 10. Divide both sides by 5. And nothing flips, right? And here's where I'm going to tell you how to figure out shading. To determine the true region, right? Rewrite inequality and then this is the thing here. If you end up with y is greater or y is greater than or equal above, sorry, I'm going to change this. The region above the line is true, right? If you end up with y is less than or y is less than or equal to the region below the line is true. Example, y less than or y is less than or equal to. So this could be dashed or solid depending on the situation, right? But what remains the same is still the same. If we have y is greater than or y is greater than or equal to, everything above is true. So I keep in mind that if this is true, then obviously this would be false. And if this is true, everything above would be false. So the way the line is pointing, that will be exclusively dependent on the situation. All I'm focusing here is on finding the true and false regions, okay? So keep that in mind. That eliminates the need for doing the test point, okay? So from now on, we won't really meet the test point anymore because of this. Okay, we know that this is true. And the same can be said by a horizontal line, like if it's y equals, it's still above or below, right? It's still the same concept applies. Okay. Are we good with writing this down? Yeah. So let's go back to this example, right? So given, right, since we have y is less than, right, true is below the line. Okay, so this was almost like an aside, a rant, right? So we have this is x and this is y. If I use a scale of 1, we're fine. So if we're just using a scale of 1, I'm just going to leave these unlabeled, okay? Just space them out equally. I should have used a ruler there. So negative 1.67 is right about there. 0, negative 2 is right about there. And before you do anything, remember that it's dashed, right? Dashed line. You normally write down the equation with the equal sign by the line, okay? Sometimes I'll have the actual inequality, sometimes it's just the equal sign. It doesn't really matter, but really if you're talking about the boundary line, it's this equation without the inequality that we're looking at. So we have true is below the line. So below the line would be everything here, right? Everything below that line would be in this area. So this is false up here. Okay. So in this case, we would have to shade if we're doing reverse, which is what I'm advocating for, we would shade this region right here. And just as an aside here, maybe I will do that here. You don't necessarily need to write this down, but just like the test point is still true, right? If you were to pick the test point, which is here, we expect it to be false based on what we just determined here, right? But let's say you forgot all about this, and this is the test point. You plug it into your inequality, right? So it'd be 0 is less than -2, essentially, right? 0 is less than -2. Right? That is false, right? And it is. It actually is exactly what we expected. So test points are still valid, but they take longer, like it's more time consuming. And but down the road, we're gonna have so many different lines that I don't want you to spend time on this here um, for you to be able to do it quickly. Okay, let's do another one. This time I'm not going to explain, and this one you should have done already, but this time I don't have to explain all of this, right? So let's do it on the back side. Number 2 is 2x. Maybe I will change this actually. 2x. Sorry guys, I know I'm messing up your notes. We will do 6x plus 3y is greater than or equal to -15. So if I asked you to graph something like this, right, we would do what we always do, x-intercept, y-intercept. So this is to find the boundary line. So for a second here, we were considering this an equation, okay? So the x-intercept would be 6x is equal to -15. Divide both of them by 6, and you get 2 point something, right? 2.5. Sorry, yeah. Thank you. -2.5? Yeah. -2.50. There it is. That's huge, right? The negative. If you forget that, everything's going to be off. And the y-intercept would be 3y is equal to -15. Divide both sides by 3. Y is equal to -5. 0, -5, that is. Put them down. Make sure that you know that the x-intercept should have a 0 here. The y-intercept should have a 0 there. Okay. So we've got our intercepts, no problem. Let's rewrite. We'll do that right under this box. So 3y is greater than or equal to -6x minus 15. We divide both sides by 3. Y, and it's not negative, okay? So this stays, it does not flip. That'd be -2x minus 5. I will box this in because it's important to me. And here I'm going to ask you to do this as well. Okay? We will say this. The line will be solid. Okay? And we will say that true is above. Does that make sense? Because if it's y is greater than, we know that the true region is above the line. So make these two notes for yourself, because imagine you have three different lines that you're graphing. You can just quickly come back, say, okay, this one is a solid line, and true region is above the line. Okay, got it. Okay, then you're going to go and graph it. So let's go ahead and do the graphing here. Hold on. Somebody's saying something. Don't tell me I forgot a sign. Okay. All right. So you've got X and Y. So we've got, I'm going to use a scale of 5. So 5, 10, 15. Then I need you to label, okay? And we're going to go 5, 10, as long as you're consistent with the gap as well. 5, 10. All right, so it's negative 2.50 and 0, negative 5. I expect it to be, right? I got a negative slope, so I do expect it to go downward, and it's solid. This is the line y is equal to negative 2x minus 5. True is above. Where's above the line? I hope you know that it is, right? This is above the line. Right? It doesn't matter which way it's pointing. Above is always north, right? Like it's always like above the line. So this would be true, and this is false. Okay. And then you shade accordingly. There it is. And we're going to do our special cases. So what have I done so far? I've tried to make you realize that when you've rewritten it, you cannot make that decision up here. You cannot make it up here by looking at the general form. It has to be rewritten for you to be able to apply the above or below the line being true. And you know why that is mainly is because you could have a negative that makes this flip, right? And then it will actually be wrong if you just go by the original, okay? So it has to be here where you make that decision where the true region is. So on your study sheet, you should definitely tell yourself, right, when is it above and when is it below, okay? So we're going to add some special cases here. when x is either greater than or x is greater than or equal to the true region is to the right of boundary line. If x is less than or x is less than or equal to, true region is to the left of boundary line. Examples: x greater than or x greater than or equal to. You will have a dashed or a solid line going that is vertical, right? This will be x is equal to a number, and the true region will be here. So if x is less than or x is less than or equal to, you might have a vertical line here, right? X is equal to a number, but then the true region is to the left. That's what you need to remember about the special cases. So I'll just tell you here on the side, right? It will have a vertical boundary line, right? If it's just x, so keep in mind that it could be dashed or solid. It all depends on what the symbol is, right? And this line could be anywhere along the x-axis, right? But what's true is that the true region is going to be to the left if it's less than or equal to, and it's going to be to the right if it's greater than or equal to. Right? And we're going to do some examples of that. So these are your special cases. We're going to do the horizontal lines as well. But the horizontal lines are very similar to all the examples we've been doing so far. Special cases continued. Y greater than or y greater than or equal to. True region is above line. Y less than or y less than or equal to. True region is below the boundary line. Maybe use a different color. Let's say your line is up here somewhere. True region would be down here. And this is exactly the same as what we've talked about diagonal lines, the same, except for here you have horizontal lines. Let's graph a few. A, B, C, D. Good. So A, let's do that one first. If you just look at that, it's a vertical line. We know that it's going to be dashed. And we know true is right. Because it's only right or left that you can pick. Okay? So if we wanted to graph A right here, X and Y, it's going to go through 5, 0, right? We know it's a vertical line that's going to go through 5, 0. So we're going to go 1, 2, 3, 4, 5 right here. And we're going to make a dashed line that goes through it. This is the line x equals to 5. And true is right here. And this is false. If we're using reverse shading, we want the false region to be shaded. And so we would shade this. Actually, everything to the left, right? Everything to the left is all false. So technically you can like continue shading indefinitely, right? So that's how you would do A. For B, let's look at it. We know that that's a horizontal line. We know that it's dashed as well. And it's less than, so true is below. Right? So horizontal line because it's only y, and it's going to go through -3. And because y is less than, we know that the true region is going to be below the line. So let's give that one a try. and -3 would be 1, 2, 3. It would be right here. And it's dashed, remember? Y is equal to -3. True is here. That means that this is false up here. So I've got A here. I've got B over here. I'm going to try to fit C in here. We know that's going to be a solid line. We know that it is a vertical. And we know that because it's less than, left is true. Left is true. So let's try that. -4, so 1, 2, 3, 4. It's going to be a solid line. As x equal to -4. True, false over here, right? So we're going to shade in everything to the right. I'm going to try to fit D in here. Solid, horizontal, above is true. Don't do this normally, but I would like this to fit in there. So y is equal to 2, so 1, 2. It's a solid line. Y is equal to 2. True is above, false is below, therefore. So we're going to shade in everything below that line. Does that make sense? Sort of. I hope it makes a bit more sense. So I'm going to give you a little summary at the back of this. Maybe it will help you with the whole shading and whatnot. Just the back side, okay? To know, right, shading, to know your shading, we will have y is greater than, y is less than, x is greater than, x is less than. And you have to know that when I do this, I also mean that it could be greater than or equal to, right? But if you have that here, true region, you're gonna have that there. If you were to use regular shading, or reverse shading. Okay, and then just break down rows like that. If it's y greater than, the true region would be above. If it's y less than, the true region would be below. If it's just x and it's x greater than, it would be to the right. If it's less than, it would be to the left. So that's something you need to remember. If you're using regular shading, your line could be looking going up, going down, or be horizontal, right? But if you're using regular shading, you shade true, right? So since the true is above, you'd be shading above like here, or above here. Okay. If you're using reverse shading, right? Keep in mind that the true region is still the same. That doesn't change, but you'll be shading the falls, right? So it'd be down here, or down here below the line, right? So that's kind of what it is. If it's y less than, it's basically the opposite, right? You'll be shading below if it's true, if it's regular, sorry. You'll be shading above if it's reverse shading. If it's this one, you'd be shading to the right. If it's reversed, you'd be shading left. Shading here, you'd be shading there. But remember, the true and false regions never change. It's just that the shading flip-flops. I would like you to focus on reverse shading. That's where I want you to focus on. And if you at all, unless I specify on a question, use regular shading, we focus on this, right? Focus on reverse. Okay. Okay, so what I would like you to work on for the rest of today, and this is also your homework, is worksheet homework would be worksheet number 2. Okay, it says linear inequalities worksheet number 2. So once you have that written down, or just mark it and put it right next to your these notes that you just wrote down, look for this handout right here. in your package. You will not be able to do the back side just yet. And if you go to the back, there's one where I give you inequalities and you're supposed to come up with the actual inequality, like write it out. Don't worry about that just yet, okay? So basically, questions 9 to 13, don't do them. Okay, so just do 1 to 8. And the rest we will do, you will be able to do tomorrow after tomorrow's lesson, okay?